So now we're going to talk about what are called piecewise functions. And probably the best way for me to show you what we're talking about is to look at the absolute value function. So we have the absolute value function. We know it looks like that. But what if we wanted to define this, okay? So we're like, somebody doesn't know what absolute value is, and we want to come up with a definition for them. Now, you've done absolute value before. You know if you take the absolute value of 5, it just equals 5, right? But if you take the absolute value of -5, it also equals 5. So in this case, it's like the identity, right? Like if you put in a positive number, you just get that same number back out. But we can't say that all the time because that doesn't happen down here. Here, if I put a number in, I actually get the opposite out, right? Okay, so we have two different definitions, and it's very specific how we define it. If the number is greater than or equal to 0, if x is greater than or equal to 0, then when you put an x value in absolute value, you just get it right back out. You don't change it. So any number, including 0, any positive number, any number greater than or equal to 0, you put it in the absolute value, and you get out the same number, if that is x is greater than or equal to 0, okay? And this is how we write it over here. This is the formal piecewise way to write it. Okay, now, that's not true, though, if we put in a negative number. If x is less than 0, we don't get x out, right? And we did that case here. In fact, we get the opposite out. So if x is less than 0, then the absolute value of x is the opposite of x. Okay, so it's called a piecewise definition. In this case, there are two pieces. Well, it depends on the x value. And piecewise definitions, that's what it's dependent on. What's the value of x? And then which piece do you use? So let's say you want to find the absolute value of -100. Well, you're going to use this piece because x is less than 0. So you're going to say the opposite of x, the opposite of -100, which is 100. But then let's say you want to say the absolute value of 32. Well, 32 is greater than 0, so you use the top piece. That says whatever you put in for x, that's what you get out. So that's how piecewise functions work. It depends on the value of x, and that's how they're defined. Okay, so we're going to give you kind of a real-world example here. It says a museum charges $5 per person for a guided tour for a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more people. Write a function relating the number of people n to the cost c. So we're going to say c of n. The way you figure out the cost, there's two pieces to it. Now, I'm going to do it different than the book because I think my way makes more sense, but I'll explain that. Okay. If we have 1 to 9 people, whoops, not x, n, it was an n. If n is greater than or equal to 1, less than or equal to 9, okay, right? So if it's a number between 1 and 9, then I'm going to take 5 times n, because it's $5 per person, okay? So say I have 7 people, 7 times 5, it's going to cost us $35, okay? If n is greater than or equal to 10, so it says if I have 10 or more people, then it's a flat $50. It's like a constant function. So we have 200 people with $50, you know? Okay? That's the way to write the piecewise function. Now, in the book, they wrote from, I'll just tell you what they did. I didn't like it. They said from 0, n is from 0 to 10, I think is what they said. But, no, they couldn't use the equal to. They must have used less than symbols. But I didn't see any point in that. And then they graphed it, though. Oops. They graphed it like, okay, you're going you have 0 people up to 9, you know, or up to 10, and then they went like this. But the thing is, that's not good because you can't have like half a person. We're not talking all real numbers here. You got to have like a real number of people. You can't have 3.5 people. Okay, so I don't really understand the book's way of doing it. I mean, I can see what they're doing, but I would have not done it that way. Okay, just a little side note on that, and I think that's all for this video.